let's talk about the things that we're able to do with quadratic functions right now. If I give you a quadratic function, then the one thing you can do to extract lots of information is completing the square. Once you can complete the square, you also just know what the graph looks like. You know right where the plot is. There are also lots of techniques we have to solve quadratic equations. Once you've completed the square, it's easy to solve quadratic equations. You just move a thing to the other side, take a square root, stick a plus or minus, and then move the thing to the other side, right? Right, so that's not so bad. If you don't have it in the form of what you get after completing the square, either you can complete the square and then solve, or you can use the quadratic formula, which is a little bit of a black box. Unless you've done that extra credit, but no one's presented it to me yet. Anyone planning on presenting that one to me? Like, where does the quadratic formula come from, extra credit? Okay, how many people weren't aware of it until I announced it just now? Okay, I thought I announced it earlier when I mentioned the quadratic formula the first time. If that affects your decision as to whether or not you want to present it, maybe I'll remind you where it is. It's right there. Do that, present it to me, you'll get some points. We can maximize quadratic. We can determine the maximum value or minimum, as appropriate, that any quadratic function takes. So what if, like, none of that is exactly what you want? What if you don't care about, like, what's the biggest that the thing ever gets? What if you care about, for what inputs is it bigger than this threshold? That's what we'll try to do today. We won't try to ask, what's the highest that a ball you throw gets, but rather, over what time interval is that ball over 7 meters up? That's what we'll do. Oh, and maybe before that, sorry, I have a non-math related announcement-ish. So, I sent out last night in like the blue gold announcements or whatever. The week before spring break, starting that week, the university is not mandating masks. Now, if you read the syllabus, I have a sentence in there saying, regardless of university mandates, I expect everyone to wear a mask. I'm pretty sure that I'm not allowed to enforce that line in the syllabus. But I'd still really appreciate it if people kept wearing masks. I guess I can't, like, hit you if you don't, but I couldn't do that before anyway. Sorry, that's a tasteless joke. There won't be any negative ramifications if you don't, but I'd appreciate it if you do. I guess there will be negative ramifications if you stop wearing masks before that point. Yeah?
Would we be able to go over where the homework problems?
Yeah, we can spend some time on that.
The February 10 open-ended.
Which asked?
It's the, suppose the graph of function q of x passes through points -2, 2, and 4 to 6. Address the following prompts. Here, compute the average rate of change of q of x plus 1 minus 2 from x equals -2.
Yeah.
Or explain why that's not a big.
So, just because that's like not quadratic-y, maybe I'll ask you this as a follow-up. Do you have time during the 2 o'clock hour? That's what my office hour is, right? No, 3 o'clock hour.
Maybe.
Okay, cool. You want to come by my office during the 3 o'clock hour, or else get into that Zoom session? I think that would be the most appropriate timing. Sorry to put you off like that. Cool. Or, like, talk to me right after class and we can say something else. So let's talk about quadratic things. Let's talk about solving quadratic inequalities. But here's a bit of setup. Dennis Mitchell has snuck into the backyard of Mr. Wilson and is throwing toss with a ball. Each time he throws the ball vertically at a speed of 50 meters per second, physics says that the flight of his ball is then modeled by -5t squared plus 15t. So there's a setup that seems awfully familiar, but I haven't asked anything about it yet. Let's ask something about it. Mr. Wilson, inside on the second floor, is reading the newspaper. As soon as the ball exceeds the height of 7 meters, it enters Mr. Wilson's field of vision. For each toss, how long is the ball in Mr. Wilson's field of vision? So let's just try to extract information. What is this problem asking you to do? Yeah. So it's asking how long is h of t greater than 7 meters? Oh, so maybe a good place to begin is like, what's the solution to that? Presumably the solution will look like an interval, and then we can just measure the length of that interval and we'll have our answer. Nice. So we have like a strategy to solve inequalities that we've used in the past. I'm going to suggest we continue to use it. Let's solve equality, and then either we'll test some sample points, or we'll look at a picture of the graph, and then just know what the answer will be. So let's do that. So we want to solve h of t bigger than 7, negative 5t squared, plus 15t bigger than 7. And maybe we'll even start by just drawing a picture. So the thing on the left-hand side, what will the graph of that look like? All right, it'll be a parabola, opening up or opening down? Opening down. So if we want to graph it, you can also check where the y-intercept is and see that it's 0. It'll look something like that. There's this line at height equals 7, and you can kind of see what the solution to this inequality will look like. It'll be the interval between those 2 points. And I drew parentheses at either end. Why did I draw parentheses at either end? Oh, I want to exclude them, because those will be points where equality happens. Maybe that's not so relevant to, like, the how long is it above, because, you know, who cares whether or not it's in or out of his field of vision at the very moment. But it's Fourier's intolerance to greater than, so there's the interval that we want. If we can find these endpoints, so solutions to equality, then we'll know the interval and we'll be done. So let's just find solutions to equality. Solve for equality. So minus 5t squared plus 15t equals 7. Let's suppose you wanted to solve that equality. What would you want to do? Get everything onto the same side, subtract that 7. That's a good idea, because I guess you're about to try to use the quadratic formula. So according to the quadratic formula, we'll get something complicated looking, I think. Time is equal to negative b plus or minus the square root of b squared minus 4 times a times c, all over 2a. Cool. People feel pretty okay? That looks like it's complicated, so maybe I'll always off to a machine. The denominator is negative 10. But in fact, does that negative sign, like the negative sign will, I could move the negative sign to the top. That 15 would become positive. The plus or minus would become minus plus, but it doesn't matter which one you do plus. So I'll make those bits of simplification when I enter it into whatever machine I use. On the other hand, I guess lots of people are taking up machines already, so maybe I'll just be quiet for a second. You don't need to see me incorrectly enter some numbers into Google. I'm sure I would screw it up. As soon as you have either of the solutions, go ahead and shout it out. I guess I haven't specified the precision, so I guess whoever it is that answers first will determine the precision I want. Yeah.
0.5789 and 2.422.
Sorry, 0.5789?
Yep.
Okay. And 2 point?
2.422.
Cool. All right. So there are the moments when equality happens. And I guess written down, like, we see this philosophy of sample times. Right, so the idea of the sample times would be, okay, do the intervals beyond those solutions give solutions to the inequality, or does the interval between give the solution to the inequality? But by looking at the picture, do I want the space beyond or the space between? Yeah, just say it louder. Yeah, great. So, in fact, I think by looking at the graph, so that is to say, without doing any stuff with sample points, the solution is 0.5789 to 2.422. And maybe I'll emphasize saying this is approximately. Because right, those aren't the actual endpoints. Those are approximations of the endpoints. All right, so back to the original question. So for about how long is the ball visible during each throw? I guess like it takes a calculator to do it, but what thing would you plug into a calculator? Yeah.
X2 minus X1.
Yeah, well, I guess that's X2, that's X1. Yeah. So how long is the ball visible each throw? 2.422 minus 0.5789. And it's visible for that long in seconds. And someone could tell me what that is, but doesn't actually matter. Yeah.
About 1.8 seconds.
About 1.8 seconds. So maybe I'll put the approximate there. Groovy. How did that feel? So, and the example I hope was sufficiently contrived to let you know that the context itself of this problem isn't what I was trying to get across. It was the content of how do you solve inequalities that involve quadratics. So, there are a few more examples, and maybe we'll even just like see the outline of what's in the notes. We'll solve a few more quadratics. And these suddenly have absolutely zero context. We'll have two that are intended to demonstrate some edge cases where something slightly unexpected will happen. And then we will close by giving a spreadsheet flowchart that will explain how to think about solving inequalities of quadratics. The ideas won't be anything terribly deep, but it's nice to have a flowchart when you can. And then we'll close by thinking about the idea of domains. So we'll merge this with something else that you already know. Cool. That seem like a good plan? Groovy. All right. So example. Let f of x be x squared plus 4x minus 12. Let's determine the x values that result in that function being bigger than or equal to 0. That is, solve this inequality. And maybe I'll, so there are one or two things that we'll do. Either I talk through this example, and then I have you guys do the next example. Or I have you all do this example, and I skip the next one. Do people think they would benefit from seeing me go through one more example? Nice. Then we'll go through this one together. And then I'll be quiet for a little bit and have you think about the next one. So let's try to solve that inequality. And there will be this two-step process. Solve the equality, and then either pick some sample points, or draw a picture of the graph, and then you'll just know the answer. So let's start by solving the equality. X squared minus 4x plus 4x minus 12 equals 0. What strategy would you want to solve that? So there are a few reasonable ones. Like the two obvious ones are, well, we have a quadratic formula. Alright, so that'll always work. Sometimes the numbers get wonky, even when they don't have to. Let's check to see if this thing factors secretly, because that's just really helpful when it does. So let's try to factor it. And just see if it does. So, if we do factor it by factoring, so we need to write it down as x plus a number times x plus a number. And what do I need? So if I want to FOIL that expression out, I'd get x squared, that's good, x times a blank plus x times a blank equals 4. So the two blanks have to add up to 4. The two blanks need to multiply together to be negative 12. And let's start with that. What's the only way the two numbers can multiply together to give a negative number? One's negative, one's positive. So maybe I could just incorporate that. Let's say that one's negative. I'll just replace that plus sign with a minus sign. Those of you who take notes in like format and pen, maybe that's annoying for you, but so it looks like I need to find two things that multiply together to be 12 and subtract together to give 4. I don't know, so what are two things that multiply together to be 12? Yeah. I hear a 6 and a negative 2. So let's see, 6 times negative 2 is 12. On the other hand, 6 minus 2 is 4. Does that do the job? So it looks like I could write this as x plus 6, x minus 4 equals 12. Yeah, it's equal to 0, isn't it? In fact, if that were equal to 12, factoring would be a terrible idea. It's not useful at all if it's equal to 12. Two things multiplying together to be 12 doesn't tell you much useful about them. It's really useful if there's a 0 there, because that's the only way you can multiply two things together to be 0.
Isn't it also 2 instead of 4?
Oh, Jesus Christ. Yeah. Okay, great. But is there anything else just wrong on the screen right now?
It's negative 12 up there.
What?
6 times negative 2 is negative 12.
Doesn't really matter that much.
Yeah. We moved past it.
Okay. All right, but so, okay, what are the solutions to the equality now? Great. Cool. X equals 2, and x equals negative 6. So the only way that two things can multiply together to be 0 is if one of them is 0, so you can set this equal to 0, giving you negative 6, this equal to 0, giving you 2. There you go. So we solved the equality. Now we need to solve inequality. And maybe we'll take both approaches. So the first is like the sample point approach. So I know, so there's the picture, there's negative 6, there's 2. Now I need to pick some sample points between and beyond to figure out which intervals with endpoints negative 6 and 2 solve the inequality. What's a sample point that is to the left of negative 6?
Negative 8.
Negative 8. Did both of you actually say negative 8 independently?
Yes.
That's a weird choice. All right, let's do it. Would you rather plug it into the factored one or into the not factored one? Does it matter? They'll both give the same answer. I think here I'd rather multiply together two numbers than have to square 8 and then do more stuff. So maybe I'll use this. So let's check. X equals negative 8. We will get negative 8 plus 6 times negative 8 minus 2. See, I think that's negative 2 times negative 10 is positive 20. Does that make me happy or unhappy? Or alternately, have I screwed up the arithmetic again? I don't think I have, but some of you are giving me crazy looks. Okay, cool. All right, that's bigger than or equal to 12. That tells me Everything to the left of negative 6 is included in whatever the solution is. What's the sample point between 6 and 2? Negative 6 and 2. 0. And 0 makes me think that's a good choice. Plug it in, it's easy to plug 0 into that. What do you got when you plug 0 into that? Negative 12. Oh, and I don't care about the 1200, that should be a 0. I care if it was bigger than 0. What I wrote wasn't wrong, it just wasn't relevant. All kinds of flighty today. So, without writing anything down, the interval of numbers between negative 6 and 2, should they be included or excluded? Excluded. You plug in 0, you get something less than 0. All right, what about numbers bigger than 2? 4. Great. What do you get when you plug in 4? In particular, when you plug in 4, do you get something bigger than 0? I think so. Do you also get 20 again? I think you should get 20 again. There's some like symmetry that tells me you should. All right, so now I just need to decide about endpoints, but I kind of already checked the endpoints, right? When you plug in x equals negative 6, you definitely get 0. That's where negative 6 came from. Does that make us happy? Does that satisfy the inequality? Cool, so those should be included. And same thing with negative 2. So it sure looks like the solution is negative infinity to negative 6, square bracket, together with 2 to infinity. People feel okay about that? Any questions about how that went? There are some computations that I just straight up didn't write down, but hopefully you felt okay about even those. Let's see another approach. Let's see an approach that avoids doing any of the computation. Well, you just have to find the points of solution to equality. So let's draw a picture of the graph. So let's see, there's the axes. I want to know when this thing is equal to 0, and I know it is equal to 0.
Did you move the sheet up?
Oh, yeah. So I'm going to try to draw a graph. So I know right now that the function passes through those 2 points. Negative 6, 0, and 2, 0. And if you look at the thing that you're graphing, well, it's going to be a parabola. It's a degree 2 polynomial. Upward opening or downward? Upward. So I can draw a picture. I'm not going to try to figure out where the vortex is because I don't care. So I'll just draw a parabola. Its graph looks something like that. So I care about where this function is bigger than or equal to 0, just by looking at this picture now. Do I want the space between or the space beyond? Beyond, right? Because that's where the y values are positive. So I can just look at this graph and see, oh, here are the places where the y values are bigger than or equal to 0. So I must want this as my solution, the x values underneath those y values. That seem pretty okay? Awesome. All right, you all think that you're ready to do one on your own? Well, on your own is a stretch, right? You can always talk to each other and you can ask me any questions while you do it. There is an inequality of x squared plus 4x minus 5 is less than 0. Less than 0. And I guess that's step 2. Oh, it has both options. Alternately sketch a graph, so pick one. Either evaluate or sketch the graph. Everyone seems to be doing it. But maybe I'll just say, if anyone doesn't know where to begin, go ahead and raise your hand. Okay, cool. very quiet. You can, if you want, consult with each other. People ready to come together? So, let's see. What are the solutions to this inequality? What is the solution to the inequality? What's the set of all solutions to the inequality? Yeah.
-5 to 1 from the above.
Cool. Any other answers given? Anyone want to discuss? Cool. Yeah. You solved the equality, and then maybe you drew a picture. You said, I see that I need the space between. Maybe we'll just, by show of hands, when you solve the equality, there were a few approaches. How many people used the quadratic formula? How many people completed the square? Cool. I wasn't expecting so many things for that. How many people factor things? When factoring walks, it walks well. It doesn't always walk. Nice. So there are two edge cases that I want to mention. So here is a quadratic, g of x equal to x squared plus 4x plus 12. Let's determine when that thing is less than or equal to 0. All right, so play the game. First things first, solve equality. So let's figure out when that is equal to 0. Those will be the x values where it might change from positive to negative or the opposite. So let's go ahead and do that. I don't know. So far I've used the quadratic formula. We factored once. Maybe I'll complete the square on this one. So completing the square, you could re-express x squared plus 4x plus 12. So let's see, that 4x, that's like x squared plus 2 times 2. So I need this last term to be 2 squared. 2 squared is 4, so I can take 4 out of this 12, and that leaves me with 8 left over. Oh, 2 times 2 times x. So far I haven't done anything interesting. 2 is 2 times 2, and 12 is 2 squared plus 8. But the point is that this thing is x plus 2 squared plus 8. So I would like to know when that is equal to 0. Guess that's equal to 0 when x plus 2 squared is negative 8, or when x plus 2 is the square root of negative 8, plus or minus. Is there anything wrong with this right now that you see already? What's the wrong thing you see?
Negative under a square root.
Negative under a square root. In fact, you could have objected even earlier. This thing says that you have a perfect square that's negative, but a perfect square is never negative. So, how many solutions does this equality have? None. No solutions. So that tells me that one of two things happens in terms of equality. So that means that either this function is always positive or this function is always negative. One of those two things happens. How can I decide whether it's always positive or always negative? There are like lots of different strategies here. Sure, let's sketch the graph. So here's what I know. I know that if I draw the picture, it never crosses the x-axis. It never even touches the x-axis. Will this thing be upward opening or downward opening? Upward opening. So I guess that means the vortex itself must also be above the x-axis somewhere. So it couldn't possibly be that, because that would cross the x-axis. All right, so looking at that graph, is that function always positive or never positive? Always. So what's the solution to the inequality? So I want the inputs that result in the inequality being true. So you told me, based on this, that this function, g of x, is always, that's how you spell always, bigger than 0. It's always bigger than 0. So is this function ever less than or equal to 0? So I'll ask you again, what are the x values that solve the inequality? Oh, there are none. There are no inputs that solve the inequality. G of x is always bigger than 0. So that means g of x is never less than or equal to 0. That's the inequality I want to solve. I want to know when g of x is less than or equal to 0. So g of x less than or equal to 0 has no solutions. Right, so that's one of the weird things that can happen. If the inequality is never, if the equality is never true, it might be that the inequality is never true. Let's suppose that we plot the example a little bit. So maybe off to the side in blue, I'll do like a what if. What if I wanted to solve instead g of x bigger than 0? So now tell me, all of the same analysis, when is this exact same function bigger than 0?
Always.
Always. So it looks like the solution is negative infinity to infinity. So those are the two options. If there are no solutions to equality, then the solution to inequality is either everything or it's nothing. That makes sense? All right, so there's one other edge case to worry about, and it's demonstrated by this. Let's let phi, that's the Greek letter phi. You also shouldn't trust my Greek pronunciation or any mathematician's Greek letter pronunciations. If you want the correct pronunciation of that letter, you should speak to a linguist or possibly a historian, not to a mathematician. Anyway, let's determine the x values for which phi of x is strictly bigger than 0. Let's solve that inequality. So, the exact same starting point. Let's solve equality. Let's try to set this equal to 0 and solve. All right. Let's take a strategy. So I guess either tell me what the solution to that equation is, or tell me what strategy you would want to use. Solve that. Yeah.
Is that a perfect square?
I think it is a perfect square.
That x minus 1 squared.
Yeah, so I want to solve x minus 1 squared equals 0. Let's go through the motions. So first you can get rid of this square. What's the square root of 0? 0. So does it matter if I put the plus or minus? So what's x? oh, cool. So this time, this inequality has only one solution. The equality has only one solution. It's that. All right. So let's sketch a graph and then read off things from there. So, in fact, as long as we know it's a perfect square, what does the graph of x minus 1 squared look like? It's a parabola, upward opening, and it's shifted to the right by 1, I think. So the graph of this function looks something like that, where there's the point 1, 0. All right, so now let's just look at the graph. I know it says some other things here, but let's just ask, do these x values result in a y value that is bigger than 0? So the y values over, x values over here, they result in a y value that's bigger than 0. And I want bigger than 0. So these are all solutions, they're all solutions. What about x equals 1? Does that solve the inequality? No. It gives me a y value of 0. I want to solve strictly bigger than 0. So I need to exclude 1, and then numbers bigger than 1. Do they solve the inequality? Yeah. So it looks like the solution to this is everything except for x equals 1. Let's write that down. So picture is these solve the inequality. These solve the inequality. But I need to exclude that point because that point has y equals 0 and I want y strictly bigger than 0. If it were bigger than or equal to, then it looks like it would be all real numbers instead. All numbers but x equals 1. Or right, there's another way of excluding 1. Everything bigger than 1 together with everything less than 1. Oops, that's annoying. Groovy. How did that feel? Does that feel okay? So here is a spreadsheet, which, not a spreadsheet, a flowchart, which is something worth thinking about. But ultimately, it's just the logic that we used. If you want to solve degree 2 polynomial bigger than k, bigger than or equal to k, less than k, or less than or equal to k for any constant k, step 1, solve equality. That's exactly what we did. There will be one of 50, there might be 2 solutions, exactly 1 solution or no solutions. In the case of 2 solutions, either draw a graph and read off what the solution is, or pick some sample points, read off what the solution is. And maybe you even know what the possible answers will be. It'll either be negative infinity to a number, together with that number to infinity, or maybe it'll be the same thing with square brackets. Maybe it'll be a number to a number. Maybe it'll be the same thing with square brackets. Those are the options. If there is exactly one solution, then again, you can either sketch the graph knowing that there's one place where it's equal to 0 and you know if it opens up or opens down. Equals k, I guess. Do that to figure out where the inequality is solved, and as always, be careful with your endpoints. If there are no solutions, then that means that the function is either always bigger than k or always less than k. Decide which one. So the 2 options in this case are either everything or there's no solution. Does that feel natural enough? And hopefully that just summarizes what we did with the previous couple examples. Good. So in order to prioritize, I think I might blow by this practice, though maybe I'll come back to it because it's a useful, like, how to think about multiple choice questions problem. Let's ask a question about domain. We'll come back to this. Oh, I guess as long as I'm like advertising something about test-taking strategies, there's a quiz sometime next week. It might be Monday. There's a sample posted on the webpage for that quiz now. There will be a solution to that sample posted in the not too distant future. Let's find the domain of this function, the domain of the square root of 1 minus x squared. So, the domain is like the set of all valid inputs. Let's just read off every ingredient in sight and decide if any of those ingredients restrict what it means to be a valid input. Do any of the ingredients of that say that the domain might not be everything? Which ingredient? The square root. What types of numbers can I see inside of a square root? You're not technically right. You can also see 0. Yeah. But I mean, if you asked me the same question, I would give you the same answer, but it would still be wrong. So, what types of things can you see inside a square root? You can see non-negative things. So, if you want to find the domain of this function, you need to figure out when the stuff inside of the square root is bigger than or equal to 0. Does that look like an inequality that we have a strategy to solve? Right, step 1, solve equality. Step 2, decide how to solve the inequality. So, step 1, solve 1 minus x squared equals 0. And then either draw a picture or pick some sample points. The picture might be in there. So, by doing some stuff, what are the solutions to that equality? Yeah. Okay. Yeah, either a positive 1 or negative 1. That you would add the 1 to the other side. No, you would add x squared to the other side. 1 equals x squared, plus or minus 1, because that's the square root of 1 equals x. All right, so, I don't know, let's draw something like a picture. There's 1, there's negative 1. The graph of this function, is it going to be upward opening or downward opening? And I guess I should specify, I mean, this function. That'll be a downward opening parabola. So its graph will look something like that. Cool. So, we ought to know when that is bigger than or equal to 0. When is that bigger than or equal to 0? Between or beyond? Between. So it'll be an interval from, oh, I've mislabeled my 1 and my negative 1. Right, negative numbers traditionally go to the left of 0, and positive numbers go to the right of 0. Should I include or exclude endpoints? Include. I want to solve an inequality with a less than or equal to. So, what is the domain of this function? Nice. People feel pretty good about that? So from here, so there are 1 of 2 things left to do. This is just the same example again, but there's a more complicated function. So I think instead of doing that, let's talk about how you can, if you say encounter one of these on a multiple choice exam, how you can detect what the right answer is without actually doing anything. So let's do that. Without doing any computations, which of the following might be the solution to x squared plus 2x minus 4 is strictly bigger than 0? So, you see all these options, they have like some things in common, right? They have 1 minus root 5 and negative 1 minus root 5, negative 1 plus root 5. So presumably those are just the solutions to equality. So by context, just looking at the problem, I can infer that I don't need to solve equality. If the problem is correctly written, which is a lot to ask because I'm not knowing about the problem, it should be one of those. So let's draw a picture of what this thing will look like. That function, upward opening parabola or downward opening parabola? So its graph will look something like that. So if I want to know when this function is bigger than 0, do I want the space between or the space beyond? Beyond. Betweens give me negative y values, beyonds give me positive, by looking at this graph. So the solution is going to look like that. So it'll be something to infinity, together with negative infinity to something. Oh, cool. So I can eliminate this and this because they don't have that form. And it looks like now I just need to worry about, do I include or exclude the endpoints?
Exclude.
I hear an exclude. Why exclude?
Because it's same thing as 0.
Yeah. This tells me that a y value of 0 would make me unhappy. The endpoints seem to have a y value of 0. So they need to be excluded. So which one is the right answer? Looks like. What do people feel about that? So if you're thinking about something multiple choice, sometimes you can shortcut some of the computational steps. Ruby. In fact, even if there were more options where there were like other numbers, you could throw out about a bunch of options already. Right? You know whatever the answer is, it's going to look like a thing, negative infinity to a number, parentheses, together with parentheses to infinity. It's a thing worth knowing. Cool. All right, I am at time. I should stop.